Hello students, Ms. Slyman here. In our last set of notes for Unit 7, we're looking at sectors and segments of circles. So hopefully you have all these definitions from 7.1. The ones we care about in this part of the unit is that we call this area coming out from the center angle a sector. And this area down here is a segment. Okay. So if we remember in a circle, the area of a circle is pi r squared, circumference is 2 pi r, or of course that's the same as pi d times the diameter. So if we think about this circle down here, we've got a sector with a radius 14 and a center angle of 100 degrees. So we should say, we know that because it's a sector, we're coming from the center. Yeah, so that's by definition. So calculate the area of the sector. Well, we know the area of the full circle, so the area of the full circle would be pi times 14 squared. But I don't want the full area, I want just a fraction of the area. And the fraction of that area is, so area of my sector is 100 3/60ths of the full circle. So we've got 360 degrees in the full circle. I want just this proportion, so 100 3/60ths of pi r squared. And I could simplify this, but also want to leave it exact. So in my calculator, I could do 100 over 360 times 14 squared. And then I want to take that and write it as a fraction. So 490 over 9 pi, and we have no units. If we had units, we'd have centimeters squared. Now I want the length of the arc subtended. So we know that the arc subtended would be 100 degrees, but now its actual length, if we're measuring in terms of our radius, well, we know that the circumference is 2 pi times 14, and I want just a fraction of that circumference. So we call that the length. So same thing, we want 100 3/60ths of the length. Again, simplifying our fraction, we've got 180 down here. That's going to make 7 and 90. I don't believe that 7 goes into 90. So we'll have 790ths. Of course, that's the same as 70 over 9 pi for our length. And if we had units, we could call it centimeters. So putting those things together, we get some formulas in terms of our radius r and our angle theta. And we'll look at that in the next video.